Okay. Okay, sorry for the late start. So I will use Cantonese to introduce first, and one of the slides is also in English. 首先歡迎大家嚟到 Open Source Hong Kong meeting 啦，今次係2月份嘅 meeting 啦，咁你今次要有唔同嘅 speaker 就嚟到我哋呢個 meeting 去分享啲唔同嘅嘢啦。咁我首先介紹我自己先啦，咁我係 Sammy 風啦，咁我本身係一個 Python 嘅 developer 啦，咁而家都做緊啲唔同嘅 project，咁而家都寫緊啲 PHP 同埋 JavaScript 啊咁樣啦。咁我係Open Source Hong Kong 嘅 President 啦，亦都創立Open Source Hong Kong 同埋Hong Kong Open Source Conference 啦。咁我自己 Open Source 嗰個嘅community 裏邊亦都有 involve 到，例如亞洲區嘅 Geelong 嘅活動啦，同埋慕斯拿嘅唔同嘅 project 等等啦，亦都係有係例如搞咗都5-6年嘅 PyCon Hong Kong 啦，亦都係成為咗PSF Python Software Foundation 嘅 contribute member 啦。咁除此之外，亦都係一個ACM Hong Kong 嘅 member 啦。今年亦都做咗一個 ESCO 嘅 member 之一啦。咁同埋就亦都有搞open data 方面嘅嘢嘅，例如係 open data day 嘅 hackathon 啦。咁如果大家想contact 我咧，可以經過 Twitter 啦 ，Sammy 風啦，係啦。咁就首先介紹呢個活動啦。咁其實因為喺疫情嘅關係啦，咁我哋都停咗一輪嘅實體嘅聚會啦，咁所以就亦都見到都好正我個 community， 咁所以咧就早3個月之前咧就開始就搞呢個Open Source Hong Kong meeting 啦。咁就最主要就係希望多啲機會俾唔同嘅朋友去喺呢個monthly meeting 嗰度去分享啦，同埋亦都喺下半場亦都可以傾下偈啊，咁樣去講下啲 open source 嘅嘢或者 technology 嘅嘢都得啦，係啦。咁上半場咧即係而家咧就會係錄影同埋 streaming 上去 YouTube 啦，咁變咗可以多啲人去可以聽到大家嘅分享啦，亦都之後下半場咧就會停晒啲 streaming 咧，就可以喺 Zoom 裏邊咧，咁大家更加可以 free 少少去傾下偈咁樣嘅。咁我哋本身個 Zoom account 可以分埋房咁樣，咁亦都有需要亦都可以用啦，係啦。咁之前我哋都好多 event 都用英文啦，咁所以咧就趁機會講多少少廣東話啦。咁雖然今次 meeting 會多翻用英文嘅，咁所以都歡迎用英文同埋講國語啦，係啦。咁我哋其實用 HackND 呢個台灣嘅 service 咧，咁其實就會有啲markdown 嘅 page 啦。咁今次咁大家亦都可能透過我哋嘅活動嘅 page 去見得到個 page 啦。咁其實如果你有短至5分鐘嘅分享咧，咁其實可以預先喺 HackND 個打低咗，咁變咗方便我哋去 arrange 啦。咁所以今次咧，除咗係 Empire 嗰邊係有分享之外咧，咁亦都有位朋友亦都係分享佢嘅 topic 啦，係啦。咁其實可以5分鐘10分鐘或者係長少少可以半個鐘亦都得嘅，係啦。咁我哋大約係 arrange 係上半 part 嘅，大約係1個鐘頭內就到啦，一個鐘到啦，係啦咁樣啦。So for the English speaker, so this open source Hong Kong meeting, so is our monthly meeting which includes at least 5 minutes short talks and also chit-chat to share and discuss the open source technology development. So now is the first part. it will be recorded and streamed to YouTube. And the second half, we will stop the streaming and recording, so you can feel free to enjoy the discussions on Zoom, and also we can also arrange some bigger rooms with this necessary. So the default language is Cantonese because more people in Hong Kong would ask us to have more Cantonese discussion. So this is why the default language is in Cantonese, but lower with English and Mandarin are also welcome. So before the meeting, we set a handy page to call for 5 minutes Latin talk, or within 15 minutes short talk proposals, or as long as a half hour if you prefer longer presentations. So this is the background of our meeting. So we don't have much updates about the community this month because the pandemic is becomes more serious in starting from January. So this is why we will see what can we do for the Hong Kong Open Source Conference. Yeah. So and also in the last weekend, I also attend one to two presentations in FOSDEM, which is annual open source events in Europe. So in this year, they are also organized it online. So this is why I can attend it. So for the job opening, so because it is just we just finished our Chinese New Year. So I can tell that I help a company to do some consultancy, which they are also looking for the React.js developer. So with your React.js developer, you are welcome to contact me if you would like to looking for a job opportunity. So I will share the head Andy of this meeting. And head Andy is here. So we will have first talk for half hour to 25 minutes about the data in the hotlink Apache Druid. And also we have a Latin talk, which is talk about the how software update themselves, OTA update implementation in Go by Toby. So these two presentations will be on our first half of this meeting. So if you did not follow us yet, so you can follow us on Facebook. We have a Facebook page and also have a Twitter account, and also we have a meetup group as well. And we just confirm our next meeting will be on March 8th. And please pay attention that this will be on Tuesday. So we will see you in March as well. So now I pass the floor to Crystal to have introductions about the next topic.
All right, great. Thank you so much, Sammy. 恭喜發財大家，咁祝大家新一年虎年虎虎生威啦，咁就工作順利，身體健康。OK，咁can you all see my screen？
All good.
Yep, that's good. So before we start, if you can please take a moment to download the Kahoot apps on your iPhone or your Android phone, or if you prefer to use the browser, you can also go to kahoot.it and then just bookmark the page to make it convenient, because we're going to have a game and we're going to have small prizes for the top 3 player. So, okay, so a quick introduction of Imply, who we are. You probably have heard of Apache Druid, which is an analytics database for modern analytics applications. Our company is founded by the original developers of Apache Druid. We continue to support the community on events like what we have tonight. And also we are major committers to the Druid projects. We also provide enterprise-ready options of Apache Druid. So if you are a big enterprise, you're looking for a more enterprise-ready options of Apache Druid with security management and also monitoring. We also have a SaaS option, hybrid solutions, and on-premises solution for you. So a quick agenda of today. So the topics is data in the hotline. So our guest speaker tonight from UK, his name is Peter Marshall. He's going to tell us more context about Apache Druid and where and how and we can maximize the Apache Druid. Okay, and then we're going to have a quick Kahoot game for you to win some prizes. And then there's a 5-minute talks from Toby, I just found out. And then we're going to have open discussion. And also, please don't forget to fill in the survey form to collect your T-shirt. We can either deliver that to you or you can pick up from SF Express locker. So without delay, I may pass my control to Peter, so you can start your talk.
Cool.
Thank you.
Everybody. Hello, everybody.
Yes.
Okay.
Hi.
Technical test. Is my screen sharing okay?
I can see it.
Yes.
Good. That's the first test out of the way.
Yay.
That's good. Thank you, everybody. And thank you for being patient with me today. I am looking after my brother's puppy. So if you hear any barking or screaming, it's the dog, not me. So this talk today it's got a new title, but it's the same talk. It's the rise of immediate intelligence. And I'm going to talk a little bit about this new generation of databases and applications that are coming out of Silicon Valley and what they are and what they do. And in that way, introduce you to Apache Druid and what it does. And I hope it will be of interest to everybody. My name is Peter Marshall. I am a senior developer advocate. So from what Crystal's saying, Imply is very strong on community. And we have a team of people at Imply whose job it is to just make sure that everyone in the community is okay. But also we're helping people talk about Druid and also helping people contribute to Apache Druid, where even if that's just updating the documentation, which is all that I can do. I'm too old to write in Java, I'm afraid. You'll see this is my introduction slide. At the bottom there is my email address and also my website address. If you'd like to ask me any questions at all after this meeting and we don't get around to it, please just feel free to contact me and come and say hello to me on LinkedIn. So this talk, I'm going to try and do it as quickly as I can, but as clearly as I can. We're going to talk about what those applications are, talk a little bit about Druid, and then maybe get into where Druid fits in an architecture. Now, this first slide was designed by my manager. So it's the best slide you've ever seen, obviously. Everybody, yes. So at the top, we're going to talk about these new applications. These applications are represented by an extremely hot bowl of nice, spicy food. I love spicy food. At the bottom, we're going to talk about more traditional use cases. And you can see here is a warehouse full of really horrible cheese. So that's what we're more used to. Let's start there. So as database analysts or business intelligence analysts, we spend a lot of time writing queries. And we're always trying to get well-written report specifications from people. That's very hard, right? It's very hard to do that. But they give them to us because we know the database inside out. We know the business knowledge. So we're adding value because we're helping people curate the data. We have to be sure that people can reflect on really accurate, very reliable data. But those queries might take a long time for us to write. They might take a long time for us to actually execute, but that's okay because we know that we're adding value by adding knowledge. If it takes minutes or hours or even days to run, that's fine. We're not talking about people who want to make decisions really quickly, decisions that are based on exploring the data on their own. That is what immediate intelligence applications are about. Companies like Yahoo and DBS Bank and SK Telecom, they're all giving their employees an application where their employees or their customers, sometimes even their suppliers, have immediate access to the data. For that to happen, those applications need to have fresh data available immediately. And the user interface demands that the queries really execute very, very quickly. And because they become very helpful and people like them and they're very popular, unfortunately, that means we have to deal with very high concurrency of the queries. And because we want the user experience to be really fun and interesting to use, that means that it's a very interactive user application. When you introduce immediacy into a business intelligence application, you can see that the requirements are very different. In an immediate intelligence application, people are focused on speed. They're focused on socializing their results, on exploring data, and on making decisions in a very personal way, and not just access to the very latest data, but also to historical knowledge, because you need to be able to give people that tempered data experience. I wrote this blog post, and you're welcome to go and look at it, from Virtual Druid Summit 3, which was a few years ago now, and I tried to characterize what the applications were actually like. Please do go and have a read about it. It might help you think differently about the applications that you can now create. So let's look at some concrete examples. In risk and fraud use cases, there's a real need to deep dive into things, to figure out what's going on, and to do that really quickly to avoid risk. If you develop a mobile app or a website and you have this kind of interactive element to it, that might be visible to people outside your organization, to your customers, to your suppliers. And you have to have a very reliable database, otherwise you face losing them as customers. In network use cases, we know there are lots and lots and lots and lots of data, tons of data. So you need to have a database that can handle the volume, but can also still deliver that immediate intelligence application. And then in clickstream use cases, maybe that's web analytics or video streaming analytics, something like that. You need to be able to do comparisons over time, like A/B testing. But you also need to be able to explore the data, doing funnels interactively, even though behind the scenes, your data may have high cardinality. So you need to have a database that can handle high cardinality and that can also handle time comparisons really well. Now, digital advertising is, well, sometimes I hate adverts on mobile phones and websites. They really annoy me, but we have to love them because they pay all our wages. But they also have created a lot of really interesting technology. That's where data lakes came from in the first place. And that's exactly where Apache Druid came from. This is exactly the environment where Apache Druid grew up. And it wasn't written as something built for a research paper at MIT. It was built in a company that had a real business problem. Now that all sounds great, but an immediate intelligence application must have an immediate intelligence database. You need a database with very low query times so that you can deliver an experience that's personal, interactive, and really intuitive. And because of the popularity of those applications, they have to scale so you can give the audience that you want the information that they want and that you can socialize it. So Citrix are Druid users, and they said in a recent Druid talk that work is no longer a place. And I quite like that, because as we're all adapting to this new world that we're in, it's application features just like this that really make a difference. Citrix call them knowledge societies. Everyone in their business can participate in the decision-making. You also need a database that can bring in fresh data from streams, not just bringing things in overnight, but to allow people to make rapid decisions. But it also has to be able to do what we have always done, bringing in long-term historical data so people don't overreact when they're making decisions. Now, this is an application that we build at Imply. It's called Pivot. I don't just show this to you because I work for Imply and because Crystal is here. I want to show you a good example of an application that has immediacy built into it. And I just want to point out some key features that you see again and again and again with applications built on Druid. You can see that all the filtering and all the group buys and all the aggregations and all the visuals are meant to be really appealing and in no way limiting. It's very flexible, and it's the kind of application that's like the TikTok of business intelligence. You want to keep using it and do the next thing and then the next thing and see what happens. At Imply, we're all about this application and about making information available quickly, so it doesn't make sense for Imply to use any other database. In the community, you'll see stories of people who are plugging in things like Grafana, Looker, Tableau, Metabase, and of course, Apache Superset. Other people are building their own applications. They may be using Druid SQL API to do React or Angular interfaces. And data scientists are using Druid whenever they need really fast time-based aggregations. And both Yahoo and Facebook, have built engines on top of Druid for anomaly detection and for predictive analytics. I just want to show you some examples now, other interfaces. This one is from a company called Game Analytics, which allows people to do interactively real-time exploration of information about how much money they are making from their mobile games, and also like insights about performance, about the people who are using it. This example is from the Central Bank of Turkey. This isn't quite as big a data problem. Here, what they've done is they've given insight to policymakers directly about risk and liquidity in the Turkish financial markets. It's a really, really good video. Just go and have a Google at that one. SK Telecom have developed an application called Metatron Discovery, which is what you see here. And again, it's all about dragging and dropping and allowing people just to play with things on real-time data at a huge scale. So SK Telecom have 2 billion events every week going into this application. Twitter, this is their advertising exchange called MoPub. Again, huge amounts of data, but presented in a really friendly way so that people can just explore it without worrying about the speed. InnoWatts are an energy broker, I think. And as they say, power is money rather than money is power. Power is money. And they want to give their customers the ability to make decisions really, really quickly so that they can save money. They shifted away from a pipeline where everything was processed overnight and things were uploaded in batches. They just got rid of that and put Druid in instead to enable people to do ad hoc exploration. And notice on their interface, on all of these interfaces we've seen, there's no save button, there's no apply button. It's all interactive. There's no progress bar. It's quick, really, really fast. So those are the kind of interfaces and applications that we can build on top of Druid. Where did Druid come from? Well, Druid came from an advertising exchange company. If you're not familiar with advertising exchanges, if you imagine this page and I'm an advertising exchange, I'm going to offer to Crystal, Crystal, would you like to buy any of this advertising space? And Crystal say, yes, of course, I'd love to have the very first advert on the top of the page on Das Spiegel in Germany. But she has to bid for that. So there's a bidding war that goes on between the different advertisers and that publishing space. So as an advertising exchange, I have to prove to my customers with data that I have given them the best positioning, that I've given them the best click-through rates, their conversion rate is the best. And not only that we're the best, but also that Crystal is the best, that Crystal has made the right decision on where to put all of their money. So it's really, really competitive. And the people who were building this application in San Francisco wanted to make sure that their application was the very best, that it had the very latest data, and that it was extremely easy to use and to slice and dice. They didn't want to spend all of their time writing SQL queries. But the problem is they had no technology to do that with. They tried to use relational databases, they tried to use data lakes. And in the story that you'll hear, if you go online and Google the story, you'll hear that their jobs to calculate the aggregates for their user interface, instead of taking 12 hours to run, started to take 24 hours to run, and then 48 hours to run. And that just wasn't fast enough, really. They tried to use data warehouses, but of course, then run into the dreaded ETL processes, which scare everyone if you have ever used them, and maintaining those and fixing your schema, it just wasn't workable. They tried lots of different things. Ultimately, they found 4 problems: that their data infrastructure was unscalable, that the data sets were all disjointed, that the user application was really limiting, and they had what I call a distance of speed. So there was a huge latency. Here's all this data that's being produced by all of these applications that we have, and yet here is the person trying to look at it, and they can't see it for days. So quite madly, they decided, I know, I will build a database. So they did. I mean, I don't know who would do that thing. These guys did, and they built Druid, what later became Apache Druid. And if you look on the project site, you'll see it's a high-performance, real-time analytics database. What does it do? So Druid breaks up its data into time periods first, because to quote Target, the US retailer, everything in business is about time. So they started there. Then they columnarize the data and they localize the data. They index it, they compress it, and then they parallelized all of the operations on that database. And because it was built in the era of cloud already, it's a database where ingestion, storage, and querying capability are all independently scalable to suit exactly what you need the application to do. And resilience and high availability, you just assume that they're in there from the start. And this is the user interface that they built. God, it looks a bit old now. This user interface, you can see, is exactly like the others, where the information is arriving in real time, where you can do time comparison periods, where you can pick the visualizations, where all of the aggregations are done in real time for you. If you'd like to hear more of the story about where Druid came from, do go and have a look at this talk with Eric Chetter, who's actually our field CTO at Imply. He was the first commit to the Druid repository way back in October 2012, I think. If you see Cheddar in the repo, then that's Eric. You can also read, if you are very technical and you like to know the technicalities of what they did, do go and look at the Druid white paper written by Fangjing Yang, who's our CEO, but also other committers, including Xavier, for example. Do go and have a look at that. So just after it was open sourced in 2012, Netflix started using it. and then eBay and Yahoo and PayPal and Cisco. A whole number of people then picked it up in 2016, and they're using it for video streaming analytics, infrastructure monitoring, clickstream analytics, API health monitoring and reporting. Now, why I love this is because it was built through the Apache way, and it's really, really important to me and to the Druid community that if whoever you are, you can contribute something to Druid. So just when I joined Imply and I started working with Druid, they created the user interface, what was then called the data loader. We now call it the Druid console. In 2019, the community got together and they completely rewrote how ingestion works to make it faster and more stable. In 0.19, they introduced vectorization, which makes things a lot faster. So vectorization is now in Druid from 0.19. All sorts of things happen together. It really is a database that's not built just by a few people, so you can get them to spend lots of money. It's built by anyone and for everyone. So there's three things I'd like to just point out about where to think about how to use Druid. And I'm going to use this quote from Tim Tully, who was the vice president of engineering when Yahoo started using Druid. He says, first of all, it can do very large OLAP style processing. Druid is all about statistics where time is a primary dimension, monthly figures, weekly figures, daily comparisons, this week versus last week, the last second versus the last hour. And he says that processing is on the fly. Druid is all about stuff being done on the fly. There's hardly ever pre-calculation done in a data cube or in a data lake or a model somewhere else that you feed into Druid. You just put it straight into Druid and the statistics are calculated, he said, in milliseconds instead of pre-calculating everything. Thirdly, he says the performance in Druid is great. Some of the tables we have internally in Druid have billions and billions of events in them. Please don't be scared. Druid is linearly scalable, so you don't have to have billions of events to make use of Druid. You can have much smaller data sets than that, but it does scale to very, very large numbers. What Eric says, my friend Cheddar, we were just talking about, he says that really the real magic of Druid is that we haven't reinvented everything. What the community has done is brought together technologies that we already know and we've been using, and we've turned them and we've pointed that technology towards end users to give them the advantage. So we bring in, we allow for flexible schemas, for example, in Druid. We can do text searching. We've got real-time ingestion from time series databases, all sorts of time-based functions, and from columnar databases, which obviously are really good for statistical calculations, highly efficient storage, fast analytic queries, and the way that all the data is distributed, and we have highly parallelized querying. So that's a little bit about where Druid came from. Now, in the next few minutes, I just want to take you on a journey with me through, I know I don't look very old. I am 44, unfortunately. I'll take you back to when I was 18. And when I was 18, I was working with Oracle RDBMS version 6, I think, and LapLink had just come out. I'm showing my age a little bit now, if you remember LapLink. But this is how all of these databases that I worked with started off. We put all of our data into something like Oracle or SQL Server, and we did all of our reporting off there. But data has this nasty habit of accumulating, and businesses have a very nasty habit of going through digital transformation, and the data and the questions change. So along comes a systems architect and they say, you need a data warehouse. So we moved all of our data from the operational database where we record what the business does, and we create a database that's about understanding what the business is doing. And now we get a whole load of new systems like Teradata and Oracle and some stuff from SQL Server, Greenplum, Netezza, whole range of things. But what we introduce here is the dreaded ETL, the thing that used to give me nightmares, where we fix what the information is that people can look at. And that project takes ages and ages and ages to run properly. But then in the 1990s, as the world woke up to just how valuable data was for making decisions, we have a new range of technologies that responded to digitization and to what Gartner called knowledge ecosystems. I quite like knowledge ecosystems. And we created a series of databases that were with these fantastic user interfaces, lots of design elements, lots of interactivity, lots of easy access to data, even if it was only summarized versions of the data. And then something happened. The internet arrived. And now people didn't scale up their databases, you scaled them out and you sharded your data just to keep up with the data volumes. And when it came to analytics, we thought, well, we can run with data warehouses. No, we can't. We had to use a new thing called the data lake. And we'd run things on it like Kylin and Hive and Trino, but we had data in its raw form. Now we don't have to fix what people can look at. We can explore that data in novel ways. But notice we still have to make the data statistically ready. But now instead of ETL, we're calling it ELT instead. 2010 comes and goes. And now the number and the types of producing data systems goes mad. Now we have mobile phones, medical appliances, solar panels, sensors in beehives. Even cows in fields have little sensors on their feet. And so the amount of data is astronomical. So now we change again, and now we think, let's put the data into individual rows and get it into the data lake as quickly as possible for us to look at. So we have Kafka and Kinesis and Pulsar, and we do all sorts of magic on that stream by doing things like Spark streaming jobs and KSQL and Flink, and then we have Beam, of course. And this is extremely cool. This is very scalable. Lots of business databases can be scaled. The data processing can be scaled. The data lake can be scaled. The analytical engines can be scaled. Fantastic. But what about the end user? That is the problem that Druid is here to solve. How on earth does an end user who's just using TikTok work out how to get at this data? What do they do? At the time, people did what the inventors of Druid did. They tried to use HBase and they tried to use Cassandra. But as we've heard, it just is too slow for immediate access. So Druid has come along. Druid is an OLAP database. It can take data from the lake and make it fast enough for you to build applications that give you immediate intelligence. And I can directly connect to those streams of data like Kafka and Kinesis. Quoting someone who's using Druid for exactly this architecture, Druid is the best implementation of a Lambda architecture available today. Druid-powered applications have very fast statistical computation. They're used by lots of people. They allow ad hoc conversations to take place with the data that's theirs to start with. Everything about Druid is about speed, about the flexibility of applications. There are 4 things that it does very well. It compresses the data very carefully onto a timeline. It has secondary indexes, which are very difficult to manage on data lakes. It does operations on compressed data as a priority, and it materializes the end result right at the very end because that's much cheaper. The cost of this, though, is that Druid is a database. Data has to be ingested into Druid. It's not like a data lake where you just scan the data using one of your query engines. But the promise is extreme query speed, the kind of speed that you need to build applications like are being used by Twitter and Yahoo and Netflix. Druid can consume data in batches. I can also do it from streams directly. So just thinking back to the differences, this ingestion and optimization of data is one of the reasons for the high performance. Other engines don't ingest the data and they don't optimize it in the same way. So they're a bit slower, but that's fine because in the slow lane, I can do things like use spot elasticity or federate my data sources. And I can look at things that I haven't looked at before. All of these databases are fault tolerant, they're shared nothing, they're elastic. With Druid, for example, if you want to query more data, you just add more resources. Excuse me. If you look at the Powered By page for Druid, what you're going to find is a group of organizations where you have some people using things in the slow lane and some people using things in what we call the fast lane. Stitch Fix are using Druid. They have a model exactly like this. They use Spark on their data lake for analytical tasks that it's okay to take an hour for. They have Presto for queries that take, say, 30 minutes. But for an application facing their customers where interactivity is really high, when the analytics needs to be really flexible, they use the Druid database. This is the Powered By page. Please do go and have a look. Somebody you know will be on this page. And of course, there are lots more people that remain completely anonymous. And if you'd like to know about what any of these people are doing, please feel free to email Crystal or me, and we can tell you about what they're doing with Druid. There's also a Druid forum, and in there, there's a tag browser. So if you're using something like Kafka, you can click on there and see all the videos and all the blog posts that people have put about Druid being used with those technologies. You can also download a quick start from the Druid project page, but there's also the Imply training program. It's completely free to register, completely free to use at learn.imply.io, and it will take you through what we call the Apache Druid Basics training course, and you can see exactly how to use it in a very simple way. And if you want to speak to me, community@imply.io will get you through to me. Please say hi. And that's me. Thank you. Crystal, over to you.
Thank you so much, Peter. So let's see. Let's play some games, shall we?
Yeah.
Yep. All right. Can you see my screen?
Yes.
Yes.
Please get in. The pin is 108040. Come on, no player yet.
Oh, I don't think we can see the right screen.
What is the pin?
Yeah.
Oh,
Yeah,
the game
just
pin
use
is
your
on the
Zoom.
top, 108040.
So, Crystal, you are sharing the other screen.
Yeah.
You are not sharing the Kahoot screen.
Oh, sorry.
Sorry.
Sorry. Hang on. Sorry. Let's see.
The music sounded good though, Crystal.
I always like the music. Okay, let me try it again. Okay. Is it okay now?
Yes.
Better, right? Yay, Toby. You're the first one. Nicholas. Calvin. Three 7690. Whoever that is, you have to tell me who you are. Unless you're not gonna collect your there would be small gift, you know, if you are the top 3. Okay. How many participants do we have? Okay, now we have 7. Come on. All in? Let's give it a couple more minutes. Does anyone know of a ways to make Kahoot continue the music? Okay, shall we start?
Yes. Let's see if I was clear.
Yeah, let's see. 2, 1. What is the focus of the Apache Druid database?
Yes.
WT is leading the way. What kind of database is Druid? Whoa. WT is still the top. What's an immediate intelligence application like? Wow. What is Druid's heritage?
Yes.
Wow. WT, come on. I want to know who that is. Which of the following statements about ingestion in Druid is not true? Not true, okay?
Ooh.
Wow.
Ooh.
The last question. How do query engines differ from Apache Druid? Oh, I love this one. Query engines cannot sing songs, but Druid can. It's got to be it.
Excellent.
Hagen.
Oh.
John Law. WT, is it William Choi? It's got to be you, aren't you?
Very good.
Yay, congratulations.
So what are the prizes?
What are the prizes? You get to, we buy you coffee. You get, we get Starbucks a gift voucher. Please send me an email. Let me type that in. I assume you use your real email when you register, right? Anyway, type to crystal.chan@imply.io. I will have that email to your address to collect your coffee. Thank you so much for playing the game. I hope you enjoyed it. So now I should pass my control to Sammy or Toby. Toby have something to share, right?
Yes. Toby, would you mind to share your screen?
Yeah, testing. You see my screen?
Not yet.
Okay.
Nothing.
I think
I can see it now.
Yeah, it zoom into my camera instead. I'm using OBS for this, so.
Yay.
But you cannot override the full screen.
Yeah, okay, nice. So, quick introduction. I'm Toby Chui, and I'm a full-time student and open source developer on Golang and JavaScript. So today I'm going to share something I discovered recently, which is the OTA update in Golang and how it works, right? Let's see. So just a really brief introduction. What is OTA update? OTA updates is over-the-air updates, which I guess everyone see a Windows update before, which is an OTA update. And OTA update should be simple, right? And yes, to some extent it is simple. Sometimes many projects use them, especially in open source project, JavaScript or PHP project use OTA updates. Like WordPress, you can update WordPress within the WordPress itself. So yes, in theory, it's simple, and you can change file in runtime if you're using interpret language. Some hardwares like Arduino or ESP8266 with bootloaders can also do that. They download a binary package of the compile program. Simple, right? And yes, to some extent. And I'm hearing some feedback. Anyway, hardware with no OS usually do that with a bootloader so that they can load a binary into the program space and then update their program in runtime, right? How about compile language like Golang? So Golang can't do override updates because Golang is a compile language developed by Google and open source by Google. A compile binary cannot update the binary itself as it is locked by itself. So any solution to that? So when I'm developing the RSOS, which is one of my longest period of time of an open source project, I ask around and see if anyone have an idea on how to do OTA update on Golang applications. And JSurf, my lecturer from NCKU, who is an expert in writing compilers for RISC-V processes, he suggests a method to use a Linux partition to separate the device into two partitions. So one is for current running program, another one is for the program that it is writing updates to, so that with a specific design loader, it can switch between a running program and an updated program of the device. This method usually used in embedded device and embedded Linux, but doesn't really work on Windows, which RSOS, my open source project, relies on. So I asked another guy from Taiwan, which is called Yami, who is the author of a Golang written social network platform called chit-chat since 2016. He suggests use a method called updater, which the main program start and update applications, and the update application terminate the main program and do an update by overwriting the files, and start and detach another main program, a new updated one, and then continue the job of the old main program, right? But this doesn't really work with systemd. I'm not quite sure about why. I guess systemd works with PID, the process ID of the running program. So if the updater kill the main program that started from, and the systemd will assume it's dead and then try to restart it. So that might not be good. I have searched for a few open source solutions on this, and the most closest one I can find is called Go Update, which is a Go library, open source, many stars on GitHub, that do the following. So the library, first of all, unlock the file forcefully, and then download a new binary, overwrite the old one, and then copy the binary content to the old file content in runtimes. But the library isn't quite well written, so we decided to write our own with a launcher style. So a simple logic of the launcher will look like this. First of all, the launcher start, it checks for any updates file in a particular directories within the embedded system or the runtime environment. And if yes, it apply the update, override the old applications and start the main program again. Detect if it is actually crashed during the first time startup. If it did crash after a few retries, it will try to restore the old version, just like what Windows Updater does. And if it didn't crash, it will try to hold on and let the main program block the operation of the whole launchers and continue the main programs. When the main program ends, it checks is another update necessary, and if not, it will just continue this cycle, right? And this launcher is still work in progress, but in theory, it also works with other kind of binaries, like C# compile binaries or other kind of binaries that you might think of. So this is how it looks like now, the RSOS system. in the latest version of the system, you can actually go into the updates tab and press the update buttons, just like you update your, I don't know, Android phone OS or other kind of system updates. It will download the updates and then do an update on here. So after the download completed, you will click a button, and then in this moment, the main program exceeded and pass the control back to the launchers and let the launcher to do the upgrade process as shown in the previous diagram, right? So yes, after upgrade, the web interface enable the ping the server so that the front end knows that its update is finished, and then it will start to refresh the pages. So this is how a web OS or web desktop system do an update on system runtime. So yeah, this is really a brief introduction of my discovery recently. And if you are interested in the source code, there's a launcher source code right there and the RSOS repo right there. Have a good evening. Bye.
Thanks, Toby. So I would like to ask there are any questions to our speaker in the part 1 of this meeting. Just like any questions to Toby and also to Peter as well, or Crystal. Yeah.
Hello. Yeah, I want to ask Peter about the Druid. If we already have a data lake, how do we integrate with this application? And also we also and in our company already have already deployed the Elastic. So I think and also we plan to do some Power BI and or Tableau solution. So that what's the position or how to integrate such application to our infrastructure?
Okay, cool. So Apache Druid can ingest from most of the major cloud data lake providers. So S3, Azure Blob Storage, I'm having to think of them all now, GCS, and you can just ingest from there as a source, and it will ingest it and bring it into the database for you. So that's how you get the data lake stuff in. The application layer is just a SQL API that you can call. There's also a more advanced one called the Druid Native API, but the SQL API uses Apache Calcite as the interpreter, and it works absolutely fine. There's hardly any overhead at all. So as long as your application is able to call SQL, in fact, it's just using Avatica for JDBC then as well, then you can just query it that way. And to have a mix is very common. Elastic is brilliant at searching text, for example. So there's a network operations center that I've worked with, and they have Elastic for searching the logs, the huge volumes of logs. But when they want to do the aggregates and they want to do the statistics and they want to do those really quickly, they use Druid with an application on the top of it.
So that we are using the Azure Blob Storage, so that we don't need to use any Kafka to data sync. We just subscribe a Blob Storage is fine.
Yeah.
Okay.
Quite often people will use Airflow just to keep an eye on the ingestion. So there's an API endpoint that you submit the ingestion jobs to. So quite often people will have Airflow at the front of it just to do the regular posting of the batches. But yeah, then should you want to start using Azure Event Hub, you can have them both running at the same time.
Thank you. Scotty, you have a question?
Yeah, Scotty have a question, so I forward on the chat. So he asked, what is the relationship between Impact and
Shall I answer that, Crystal, or would you like to answer the question?
Yeah, go ahead, answer it.
So it's a good example here, actually. So I work in the open source community. So we have lots of people that we know, and you may have seen me in the channels or one of my colleagues in the channels and giving talks at Apache Druid Summit, etc. All of that. So there's a team dedicated to that at Imply, and our CEO and the CTOs are really very strong on supporting the open source community. And when they founded Imply 2015, I think, its mission was to help people use Druid more effectively and to help people build applications on top of Druid and succeed. So that's, I'm sorry, I'm pointing, Crystal, I don't know where you are, but that's what Crystal represents. So we've got products that help you manage it, deploy it, visualize it using in Pivot. And so my relationship with Crystal is, that's, I talk about Druid and how brilliant Druid is, and Crystal talks about how brilliant Imply is.
Right. So basically, Apache Druid is part of the Apache Software Foundation. Okay, so we contributed into the open source community. You can download it. There are additional features that you can find from Imply. Where, for instance, like what mentioned by Peter just now, we have a Imply Pivot. Of course, you can build your own application and connect to Druid just fine. But we do have for instance, we have a user interface called Imply Pivot that you can use. We have manageability tools, monitoring, and security patches. For instance, with the Apache Druid technology, you can write your own patch, for the log4j. But if you use Imply, then you have people with SLA supporting you. We can release you the patch like in 24 hours when you have a vulnerability that discover. So that's the additional value that you have the options to subscribe to with Imply. And we also have SaaS options. A lot of the enterprise customer are looking for, time to market. They don't necessarily, especially in Hong Kong, not that many enterprises have lots and lots of developer, and they want the technologies, but they want to be able to adopt it and quickly launch it out to the market instead of spending too much of development effort. So that there's an options that we have an enterprise ready option for you, and that's what's provided by Imply. So does that answer your questions?
Yes. Thank you, Crystal, and thank you, Peter.
Yeah.
Okay, so this questions from Ben now to Toby. He asks, what is the purpose of your project? Why you will also update it for all platform or something else?
Okay, that's project basically is a subset of the RSOS project, which if you have heard about RSOS project, which I have show on the previous Hong Kong Open Source Conference, which is an open source cloud web desktop environment system. And this updater is particularly designed for that platform so that it can update the platform to a newer version, right? But by changing a few parameters, you can also use that packages to update any kind of Golang written code to, deliver it to your clients or deploy to different cloud systems. So yeah, it's general solutions that fit all, but we're still working on it. And I just want many more people to know about this project. So if there are any comments or any feature they wanted, we can add it to the system, or add it to the launcher as well. Yeah. Thank you for your questions.
Thanks, Toby. So any other questions or other sharing in the part one of this meeting? It seems low. So thanks for Peter and Crystal and Toby for their presentations in the part one of this meeting. So I will start the recording.